Good morning. Subject name compiler design. Previously we discussed about various topics of compiler design. Now today we are going to discuss about the concept of the one of the conflicts that is arises in shift-reduce parsing that is types. Another one is what are the different types of parsing mechanisms. In that we are going to discuss about LR parsers mainly. Okay, that is the main agenda, and the outcome of this content for this today's session. What are the conflicts that are arises due conflict in shift reduce parser, and also describe about various types of parsers. Each one details in detail with an example. So that is the first one. What are the different conflicts that arises during shift reduce parser? Now here the first one shift reduce parser, and second one is a reduce parser. Shift reduce parser, and second one is a reduce parser. A shift reduce conflict. Shift reduce is the one. It can be two actions. One is a shift action, and second one is reduce action. That means it performs both the action. Then only we can say that it is a shift reduce. And then the conflict is to be arises. That indicates that the conflict arises, indicates that the which of them action to be processed. While continuing the example, we will see with an example how this action. And second most one is reduce, where this conflict occurs. Here two different that is reduce actions. That means at the same time there will be two rules which are allowed to get the resolvement of these actions. Either reduce actions. Here previous one is shift reduce. Here we will getting one is shift action, and the second one is reduce action. Whereas in the second case, reduce action. One is reduce action, and second one is reduce action. That means these two are to be performed at the same time. This is also be at the same time. So where this existence of these actions coming at the same time, then we can say that this is a conflict of shift reduce, and this is a conflict of reduce, where two reduce conflicts are occurring in this mechanism. Now let us see how through an example this occurrence of first one we are going to describe about shift reduce conflict, where this arises. For example, consider the grammar E plus E star E parenthesis ID. So this is the given grammar. So we are going to get the given grammar is accepted or not with the stack implementation. We know that the stack and there is input, and then action is to be taken place. So here the action means it performs shift action or reduce action, and this etc. So here the action may be shift action, reduce action, or shift reduce, or reduce. So previously we discussed about action types. So this here the action types, it may perform depends on the availability of the grammar to get the conclusion of the starting of the grammars. Now let us see here. First initially $, it is the stack is empty, and the input, what is the ID plus ID star ID. This is the given input string. This is to be considered, and it is to be placed at the input only. Then we will start with each input symbol that is pushed onto the stack. Each and every symbol of the our input string is id plus id star id. Now we are going to process each symbol um, one by one to the stack content. Now here id first symbol is identifier, so we have sent, and any mapping is there. So here e derives id, so that's why here id, then e derives id, since e derives id, so we are getting this e. Now the next most symbol that is available ready to give the input is plus symbol. So this is to be processed and sent to the stack. Now any deviation, that means any deviation here in this case for getting the result, there is any other production. So here production is e plus c, e star e less process id. So there is no substitution or any handle to get this one, resolve this one. So that's why we will take one more further input, that is id. So id is entered. Now id also same, so that's why we are taking e plus id, which resolves e plus e. Why? Because e derives id as the first rule, second rule, third rule, fourth rule. As the fourth rule, we applied this one, and then we get this result e plus e. Now any rule which can apply and get the result. So here you see once again star we introduced, and then we have placed onto the stack upperly, and then next id identifier, next this identifier also, then we will get the string that is a stack content, that is e plus e star. Now every time what is the symbol we are going to be inserted into the stack, we are going to perform, that is a shift. But here reduce. Why? Because the symbol that is to be resolved with the substitutions, those to be considered as a reduce action. So that's why here it is id substituted, and we got this one. And next we introduce that input symbol to the stack, that is shift action. And here also reduce, where we resolved at the handle. Then but identifier, so here we see that there is a chance of either applying shift or reduce. Why? Because we have a chance whether to verify the given grammar is performing the shift action or reduce action. So for example here dollar, that is stack content. What is the stack content that is available? E plus e. Now e plus e. And what is the input? This is the stack. And what is the input here? Input is star id. Input is star id. Now as per the given rules, e plus e, which contains e derives e plus e, that is to be applied. When this is applied, we can say that it is a reduce. It is reduce action, e derives e plus e. There is also a chance of applying the movement of e plus e star. That means star is moved to the stack content. So we can say that e plus e star. So that means here shift operation we performed, and we get e plus e star. Or there is also another chance is e plus e can be reduced to e plus e is reduced to e. So you can perform $e also. So either shift operation or reduce. There is a chance of applying the two actions, but which one is to be considered? This conflict is called as shift reduce conflict. In any other case, if you see two actions at a time, possibility of applying both shift action as well as reduce action. Here shift action is E derives, that is a star is to be inserted into the stack content, top of the stack content, that is shift action. Reduce action is E plus E derives $E. That means E plus E, because of this rule, first rule, we can reduce this one. So which one I can apply depends on the context. So this is called one of the conflict called as shift reduce conflict. That means at a time getting the chance of applying both shift action and as well as reduce action in the given grammar to get the start symbol of the to process the input string. So after this we applied identified, then that is shift action, then automatically we applied once again reduce E plus E, then E star E, which can once again E plus E, once again we'll get E. So in this way we get the result of, that means finally $E, we can say that it is accepted. Since it is a start state, of the symbol and for the given grammar, then we can say that it is to be accepted. So handles we applied, but how to do this task depends on the context, which one is to be resolved. So this is to be considered as shift reduce conflict. One more is reduce conflict. That means at a time chance of applying the reduce. But here also one more example here. For example, if you consider if then yes, but here if then yes is to be considered as yes. That is one option. What is called as the reduce action, and we can also have the choice of if then yes and else also we can put, and we can say that shift action. We can say that is shift action. We applied reduce and then we got yes. Since it is a start symbol, grammar is accepted. Now one more other choice also, not yes, else. So here one thing is $if then E then yes. There is a chance of applying if then s resolve to yes, and the action is reduce action. And the action is reduce action. And the action is reduce action. Now we can also say that else is to be, but else yes, else it is not there. So that's why there is a chance of applying, but it may not give to the result. Whereas the second case, if E then yes, if E then yes, here else part is there in else part which is available in as input else. Now previously what reduce we applied, then we reached and then we didn't get the result. At that time we can also say that apply either shift operation. Since there is a possibility of applying shift also, then we can say that reach shift. So here we applied this one. If E then yes, then else is moved to stack from the input. So if E then yes else. So the remaining dots are there. That means maybe sometime next S will also come into the next time. So this dot indicates the remaining remaining things are also available. So it may occur at in any other stage, the later stages. So what is the thing here is we have to note down the two important points. One is reduce action is available, and also at the same time one more reduce action. That means two more reduce actions at a time, possibility of applying. So we can consider either which one. So generally we are going to see that reduce, we can see that what is the result favor we can consider. Now second most is reduce conflict. Second case is reduce reduce. Applying. This is the first grammar, second symbol, third rule. C drives AB, A drives small a, B drives A. Now what is the input? We have to process small a, small a. But whenever the first symbol is moved to the stack from the input, that is accepting one symbol from the input and placed in the stack. So here for the first symbol A, I can resolve either A, capital A or capital B, because it is also performing what? Reduce. Here also it is performing what? Reduce. So reduce is one action, another action is other. So this is the way of getting multiple times the reduce action and for the same at the same time, then which of them is to be considered. So we are generally what is the result. So result is to be considered. So the result is to be favor of reduce A derives small a. Then that means here capital A we have applied, and then next time here after applying that one, we have taken $A, and this is the reduce action we applied. Then we move to the A dollar, we move to the stack, and then we can say that it is a shift action. Shift action. Then after performing the shift action, then the input is empty. Then AB. So what is B here? We have reduced to that capital A derives capital B derives A. We applied this one. So we got what? A. And then what is C? Here also we applied what? Resolving of this one, reduce. So reduce action to be performed, and this reduce action result to C. So what is C here? Starting result of the grammar, start symbol. Then we can say that the grammar is accepted for the specific input. Whereas if you do not take the case of capital A, instead of capital A, if you take this small b, capital B, so what happens? The result will be not released. We won't get the start symbol or the we cannot eliminate. So instead of this one, if you take capital B and dollar small a dollar, that means we applied a reduce. We applied a reduce. But what is the capital B and what is small a? Here capital B, and then we have processed, and the result is and the input is empty, and we can say that we performed a shift action. Now we can perform either capital A or capital B for the resolvents. That means we have taken reduce action. So there is a chance of here we may take either capital A derives A or small a. So here we take capital A derives small a, then what we do? Small capital B, capital A. But here, what is capital A? The capital E here. So actually C derives small capital A, capital B. But here what we got? Capital B, capital A, which is does not result to the solution. So it is failed to get the resolvement of this grammar, and that means success results are to be stuck out if we do not apply properly, and we may choose the action which is failed. Let us see various types of parsers. Previously we know that LR parser is one of the type in the case of parsing mechanisms. Here L is to be considered as left to right, scanning the input from left to right, whereas R stands for rightmost derivation in the reverse. R stands for rightmost derivation in the reverse. There are 4 parts. First one is LR0, SLR parser types. LR is first one, simple LR, LA LR, and fourth one is CLR. LALR stands for look ahead LR, CLR canonical LR, and S stands for simple LR and LR parser. So these are the 4 parts of. Now we'll take the first type, that is auto parsing. What is LR parser? So this diagram describes about LR parsers where input is to be supplied, and this input may get each symbol, and that is to be sent to the stack. Stack is to be performed. Previously you have seen whether shift action or reduce action or this go to based on the algorithm. That is one of the algorithm, that is famous algorithm, that is called as LR parsing algorithm, and we can implement either action or go to based on these two, action or go to. Then we will generate an output that is to be verified whether it is an LR parser or not. So we have seen this diagram previously also. Now we will implement this model LR parsing with an example also. Okay. Now, what are the general steps that is to be considered while implementing this LR parsing? This bracket 1 represents scanning of the input symbols at a time, at one, taking each input symbol one time. That is each input symbol one input symbol. So that is to be considered from the input. And for the given input string, what is the context free grammar that is to be obtained? And also we have to check whether the given grammar is ambiguous or not, and that is a main important one before implementing this parsing mechanism. Not only this LR parsing, any CLR or SLR, any type of the parsing also, we have to take care any ambiguity arises. Then we have to verify that given first add an augmented production for the given grammar. After checking the ambiguity, we have to add augmented grammar, and the second one is find out canonical collection of LR equal 0 items. Then we have to implement data flow diagram and then construct the parse table. So first we have to see that previously with different examples we have seen how the ambiguity is to be eliminated. So that is to be ambiguity free grammar we have considered in this given example. But what is meant by augmented grammar, that is we have to consider. So here augmented grammar is to be a grammar where the parser is trying to identify when to stop the parser. That means end of the thing to be considered by making some notation. So this augmented grammar is to be written as adding an extra production. That is, this is production. Another one, this from this we'll get S derives capital A, whereas we'll get it right this one. But augmented grammar S derives S, which gives an extra provision, verify the production in the given grammar and where to stop the process. For that reason, we augmented. That means what is the start symbol of the given grammar? Yes. So we have to take one new symbol S dash, and which derives the start symbol of the grammar. Here start symbol of the grammar is yes. That's why we have considered S dash derive. Suppose in case of a start symbol is A, suppose capital A derives B X, then we can consider a augmented production is A dash derives A. So like that we can consider an augmented production the given grammar itself by easily considering a start symbol with a dash notation. Left hand side dash notation, right hand side with the corresponding start symbol of the given grammar. So these are the three simple easy steps, but what are the canonical, that is to be main point in this example, and then data flow diagram parsing. Here the canonical columns can be identified by putting an by inserting dot symbol first position of the every production. So for example, here the production one is S derives capital A, and capital A derives small a, capital A derives small b. So these are the three rules which is there to be given grammar. So what is the augmented grammar? Augmented productions for the given grammar. So we have to implement the third step. For this third step, we have to write keep. That means we have read this one also. So we have included this S dash derives S also. So that's why augmented grammar we have taken, and then This is the augmented grammar. Now canonical collection. In canonical collection of, we have to add in position. That means dot symbol at the beginning of each of the first position of every production. So here second rule is A, we have to insert dot symbol, and third production is small a capital A, insert dot symbol at the beginning, and another one, fourth rule is capital letter as B, insert this dot symbol at the beginning of this each of the input. So like this we have place a notation, then we can say that the LR of 0 items to be processed. Before implementing the canonical insertion, I have to start with a dot symbol, and then each and every time we have to process a dot symbol, one symbol ahead towards the right. So here, if we see we have to calculate the closure of each other. So the closure of items can be calculated as I0, I0, I suffix 1, I2, I3 like that, etc. So first initially I0 is the closure. So what is the closure of, if you consider this one as the first function, that is here 0 S dash is I0, I1, I2, I3. Like this we can place a notation like this. And I0 is the first one. So that's why this production S dash derives S we have to consider. And after considering this, what are the productions which are starting with S? So those production, so S dash and S dash we have considered, and what are the after dot? What is the symbol? So after dot S symbol. For this symbol, that is for this letter, what are the productions? That means rules starts with yes. Any productions are there which starts with yes in the given one. So yes, it is the start with was. This is not, this is not, this is not. So that production is to be and then that is to be noted down. Whereas the second one, that is while considering I0, that means here we got one symbol, that is capital A. Now any symbol will start with capital A. So here also two more A is there. So that's why we have to include capital A, that is to be written. After this is not a variable, but there is no production to start with one. This is also not, there is no production starts with. Then we can and what is the result after shifting this one? Then we get this A dot A. So here S derives S dot. S derives small capital A dot capital A. That means each symbol, one symbol ahead towards this one. Small a dot capital A derives B dot. So here there is a chance of getting, why? Because the productions are available after dot symbol capital A. But here there is no, here also there is no. We can stop where there is no symbol, then we can stop that this one. So in this case, what we getting this result is A dot A, then the same thing. But here instead of this, we have to write I1, I2. So I1 is to be what on the process of S dash derives S. So we shifted this one. And I0 with A. That means second production. So I0 with S. This one. Second one, I0 with capital A. And I0 with capital. So like this, I0 with capital A dot. Once again, A productions are to be written. So these are two are A productions. Second, again, I2 with small a. So small a, what do we get? Capital A, small a dot, capital A. So this is the same as I3. So what is I3? I0 A. So and B0. This is I4. So we got I0, I1, I2, I3, I4. So simply we can, this is called as canonical collection of items. After processing this one, we got I3 also. I3, we know that what is small a cap dot capital A, which is same as the previous production. Then we got this one. B dot, there is no other productions. So we have to write I naught with B, I2 with A. So B, SA, A derives small a, capital A dot. So previous we have seen this dot production, and I naught will be calculated, and then what is the symbol which we applied? Small a. So this small a once again to be written with this I naught with small a, I3 with small a, and then we have to write all the canonical collections here like this, and then we construct I naught, I1, I2, I3, I4, I5, I6. So first initially I naught with S. So I naught with S. What is the production which we are getting? What is the productions which are getting? I naught with S. And I1, I naught with A. So that is to be written here. I naught with S. What are the productions? Similarly, I naught with capital A. I naught with small a. I naught with small b. So these are the two that is to be processed. So what is capital S? I naught with capital S. So that's why I have written I naught with capital S is what? We are getting S dash as S dot. So here we got this one. What is I naught with capital A? I naught with capital A. And that is to be written as this S derives A dot A, once again dot A. Then I naught with small a. What is small a here? We have to write. So I naught with small a. What are the productions which are, because it is a non-terminal. So I naught comma small a, which leads to the A capital A, small a capital A. But here after shifting the symbol, A dot capital A. What is capital A? What are the productions? Once again, the same productions. A derives small a capital A dash derives dot B. So these are the two productions that is to be included. And this is to be considered as small a. This is to be considered as small a. Whereas the second one, that is B, small b. What are the rules that is to be applied for small b? That means only small b is A derives dot B. So that's why we have to consider this 4. And then for remaining also, here the process is not supplied because I1 comma the dot symbol is reached at the, whenever dot symbol dollar symbol reached end of the input, that means there is no further symbols after the dot, then we can stop the process for that particular I naught or I1. So in this case, here there is no further movement of the input, so that's why we stopped. In the second case, we applied and we got I2 with applying one more case, that is I2 with chance of applying capital A, I2 comma capital A. So I2 comma capital A, we got this result, and I2 with capital A, capital A also we can get the A dot, means here we get the same, and then I2 with B, I2 with small a, and I2 with small b. So here I2 with capital A will get this result, I2 with small b will get this one. So this production, but and what is I2 with capital A, small a, will get the production. Suppose if the productions are same, which are already available in the given, we can consider as the arrow mark which points to the same symbol, instead of writing the one more rules for that state. Simply that state instead of repeating, no need of repeating the same, because um, carrying of the result I2 with small a gives the result as same as a small a dot a capital A derives small a capital A derives dot b. So these rules are to be repeated once again. If there is a difference of the output, then we can write a separate state, and we can note down this as a derives small b or dot b, and we can write this small b or small a. But if at all, if this state and this state are same, so no need of writing the same state repetition. Instead of writing the repetition, simply what we make is see any previous results with I0 or I1. So here we observed that we got the result of the three productions, which is same as already available. So that's why we simply put arrow mark, and then we can use it as a one more state, and it indicates that I2 comma A is to be stands out. Whereas the second I3, that is I0 with this one, then we can go ahead with the one more input, that is B. Then we reached here. In this case, we have stopped the process. Why? Because after the dot there is no other input symbol is available. If at all, if any other input, then we have to once again write I4 comma the corresponding input. So here there is no further, then we can stop this process at this state only. At this state only. But if you observe here also the end of the input symbol is reached, and from this here also end of the input symbol is reached, then here we can stop the process, and then finally after completion, this is data flow diagram, that means state with the corresponding transitions, and then we are going to write the rules. After implementing this one, we have to construct a table for this one. We have to construct the table, where the table contains in the above diagram what are the states available: I0, I1, I2, I3 is one, I6 last state. I6 is the start state I0. So we have to write all the states as across the rows, and columns across the columns. We have to perform either action or another one is go to. That means here the state name is I0, and the input supplied, that is here small a. Here what is small a? I0 with small a, where it is reaching, then this is shift S3, and I0 with small b, what it is reaching, it is I4, that is shift 4, and I0 with capital A, what it is here, this is a action, and this is why, because it is a non-terminal. Whereas other than variables, that is small a, small b, we have to write what? Small a, small b, we have to write the shift actions to be considered as shift action. Non-terminal, that is capital A, it is a go to action. So here go to state I2. So that's why A2, suffix is 2. So whereas capital S, the suffix is 1. So that's why I have to write as it is a action considered. That is the first row, the first row I0. And the second one, if you consider I1 second one, in this what is the other states, it is moving with the input supplied. So there are no other states are supplied, since it is a starting augmented grammar, then this is to be considered as a accepted grammar notation as the dollar initiation. So that's why this is the only input that is to be processed for every augment grammar notation for each of the examples. Whereas if you consider the second, that is I2, third, in this the state I2 state, it reaches to one more state I5 with the capital A symbol, and also one more input small b, and one more input capital small a. So here small a reaches to I3, so that's why S3 have come in, and the small b reaches to I4, so that's why shift 4. So for these two cases we have written S3, S4. Whereas capital A, it reaches to I5, so go to is to be considered as fifth 5. So for always we have to write the symbols only with the go to symbol, whereas here shift we have to write for other than the variables. Whereas the third one, that is I3, which takes the state from shifting to another processing of the result, where it is moving from one to another. So I3, this is the state. What is the input? That is small a and then small b, and these are the two things. And then with is also capital A. So what is capital A? Same state. So same state means S3, and B it goes to I4, so S4, and the capital A is 6. So that's why I go to is represented as 6. Number is 6. I4, similarly, if you observe the state I4, here what are the states that is reaching from I4? Go another state. So I4, from I4 and there are no other states. It is a final state. I4 is the final state, and I5 is also final state, and also I6 is also final state. How can you say it is a final state? Because from that state there are no other states which are to be moved, and that means dot symbol is reached to the end of that input symbol. So end of the character. So that's why it is to be considered as the final state. Whenever final states are to be considered, the production which is to be written, what is the here? What is the production? S dash derives dot s, and s derives small capital A, and then S capital A derives to small a, capital A, and A derives dot P. So for these productions, we have to note down the number wise, that is 0 I naught, that is 1, and this is second, and this is through. So what is the final state here? It is reached A derives B dot. So A derives B dot is there in which of the rule? That means here third rule A derives B dot. So you have to write what? R3 as the row corresponding to this I corresponding state, that is I4. And another state is I5. I5 is also a final state. Verify the rule which corresponds to the state I5 in the given state, in the given list of the production. Though here that is the one first rule, that is S derives dot EAA. So we can apply a R1 to this particular state of the actions as R1, R1, R1. Corresponding actions only, not go to. Why? Because it is a not considering that one, that is a final state representation only, all the states. And last one is I6. I6 is to be verified with the corresponding rules in this one. So I6 is the second rule. So here second rule is to be applied. So rule 2. So simply you have to write the R1, R2, R0, R1 for the given grammar. You have to write R0, R1, R2, and then that to be implemented with the corresponding grammar, and that is to be noted down as a rows and columns with this one. And then finally all the states are to be completed, and then we can say that the parse table is implemented, and this is say that you can say that LR parser of the version. And this one is called as data flow diagram, and this one is called as parse table of the given graph. So in this way we have noted down with an example of LR parsers. Next class we will see that concept of another types of different types of the parsers. We will come up with a new topic from the next class. Okay. For all the contents which are to be available in the textbook, that is called as compilers, principles, techniques of the others, that is Alfred, Sethi, and Woolman. And as the time, then we can meet up in the next session. Thank you very much. I love you. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.